Hello guys, so today we'll be solving Codeforces round 906 tip 2 problem C. Qingshan loves strings too. Okay, pause the video, read the question, then I'll explain. Cool. Okay, so what the question is saying that there's a character Qingshan and he will have, I don't know, he or she. So let's say he, him, they, their, whatever the pronoun they use. Sorry, I don't want to offend them. Okay, let's focus on the question. So they have or like he have a string S which can consist only of 0 and 1. Now, what it's saying that the string of k length is good only if it follows a of I is not equal to a of k I minus k of sorry, it was a of I should not be equal to a of I sorry k minus I plus 1, and k is nothing but the length. So if length is like, let's say the length as in the string length. So if k is nothing but a dot size. Okay. So if k is equals to 4, then what we can write is, and here one thing to note down is it's starting the numbering from 1. That is the indexes will be from 1. So we can write that a of 1 should not be equal to a of 4 minus 1 plus 1, that is equals to a of 4. So a of 1 is not equal to a of 4. Similarly, what we can write a of 2 should not be equal to a of 4 minus 2 plus 1, that is equals to a of 2 should not be equal to a of 3. So what we can realize over here is that the first character and the last character should not be same. Similarly, the second character and the second last character should not be the same. Third character and third last character should not be the same. That means if it's an odd length, yeah, okay. But let's read the question more. And now, what we have to do is that we have to make. Oh, okay, yeah. So we were given a string S. Okay, we know what's a good string. We know that what's a good string. That means it will have to follow this condition that a of I should not be equal to a of k minus I plus 1 for all the I, that is 1 till k, because k is the length of that given string. Okay, so that means if a string is good, then this will follow this condition, right? Now we are given a string S and Kingshan wants to make that condition, make that string good. We have condition for good. Kingshan have a string S and he wants to make this string good. Now we have one operation which we can do at most 300 times, possibly 0 as well. So at most we can perform it 300 times. And what is the operation? We can insert 0 1 at any position. Now what we need to return, we need to return if it is possible to make good S good. If yes, then we'll have to return where we are inserting this 0 1. And all we need to keep in mind one thing, that let's say if there was some string something like 0 1 1 1, so if we'll insert it, let's say here, so let's say we inserted 0 1 over here. So initially the indexes number were 0 1 2 3 4. Okay, and then the string will become something like this 0 1 0 1, because this is inserted over here, and these 3 1 1 0. Now the indexes will be changed something like this. So whenever we are inserting like over here, so we'll return the indices as per this new string. So what we have to do is, if it is possible, then we have to print the sequence. Okay, print the sequence. We'll see in the question. Then yeah, the number of insertion and the sequence when or where we are inserting. Okay, so moving this board, what we have is, first of all, we know that for any string A to be good, for A to be good, it has to be follow, and its length is k. Length is k. Then if it's have to be good, then it should follow this condition that A of I should not be equal to A of k minus I plus 1 for all I from 1 to till k. Okay, if we want this string A to be good, then we have to follow this condition. All right. Now the question, we will have one string S, and we have to make this string S a good one. Okay, we have to make this string good. So for this what we can do is, we can perform one operation. And what is that operation? That operation is, we can insert 0 1, we can insert 0 1 in this same order only, not that 0 and 1. We can string, let's say something like this, that we can insert this substring 0 1 at any index, but at most 300 times. So what is the operation? We can insert the 0 1 at most 300 times, at most 300 times, and then we have to tell whether whether this string s can be made good or not. If yes, then we will have to return how many times, let's say count times, or how many times we have inserted this 0 1 and at which indexes. We have already discussed that if we'll insert something, then it will change the indexes. So we will have to return the indices in the proper order, so that it should follow our exact insertion order, or like the exact insertion indexes which we inserted it, right? And it will keep on changing. If we insert something, this indexes will keep on updating in themselves. Now if not, then we can simply return -1. Okay, cool. So that was the question. Now, before proceeding, so let's see what it was saying when trying to, when it said that if A to be good, if A to be good, it should follow this condition, that is A of I should not be equal to A of K of I minus, sorry, K minus I plus 1. If we'll just break it down, let's say if K is equals to 6, then we can simply write A of 1 should not be equal to A of 6 minus 1 plus 1, that is A of 1 should not be equal to A of 6. Similarly, A of 2 should not be equal to A of 6 minus 4 plus 1, sorry, A of 6 minus 2 plus 1, that is A of 1 should not be equal to, sorry, A of 2 should not be equal to A of 5. Similarly, we can write that A of 3 should not be equal to A of 4, and if we'll go, it will just reverse its order, that A of 4 is not equal to 3. So cool, this makes sense. Okay, okay. But what if k is odd? That is the length of k, the length of the string is odd. Then in this scenario, it will become something like A of 1 should not be equal to A of 5 minus 1 plus 1. That is A of 1 should not be equal to A of 5. Okay, cool. No issues. A of 2 should not be equal to, A of 5 minus 2 plus 1, that is equals to A of 1 should not be equal to, sorry, A of 2, yeah, A of 2, right? So A of 2 should not be equal to A of 4. that that's okay, no issues at all. And then A of 3 should not be equal to A of 5 minus 3 plus 1. That means A of 3 should not be equals to A of 4, sorry, A of 3. Okay, but no, this is not possible, right? Because something like whatever A of 3 is nothing but the character at the third index, right? So A of 3 is not equal to A of 3. This is not possible. So what we can conclude from here is, if if there is any string, if there is any string which has odd length, that means it cannot be good. Okay, that's one thing. Okay, now, so so when we have s, we know that we can always insert 0 1, substring 0 1 at whatever place. But let's say it was odd. It was odd saying means the length of this string s is odd. So like, let's say the length is n and this n is odd. Now if it's odd, then even if we insert this 0 1, we will always be inserting two characters, right? So if it was odd and we insert two characters, then still it will be odd, because odd number plus 2 is still odd, right? So it will always be odd no matter what, how many times we insert, and we cannot delete anything. So it will always be odd, and we just realize that if any string is odd, it cannot be good. Okay, so from here our solution is split into two halves. First, if its length is odd, length, write it like, if length is odd, we can simply return no, it's not possible, and we can simply return -1 and return okay. But if length is even, now let's see what to do. Okay, so we know that if this is a string, we always start checking from here and here. That is, we can say that we have one pointer over here, and we can have another pointer over here. Okay, okay, no issues. So now let's say if there is 1 over here and 0 over here, no issues. Similarly, if we have 0 over here, 1 over here, no issues, because it can be possible, right? then we in this scenario we need to just check this new string, or I would say only this much part, right? Because this outer like this leftmost and the rightmost and over already satisfying the condition, so we need to check this much part, this remaining part, right? Okay, now similarly if let's say here also it was 1 and it was 0, or it was 0 or it was 1, so in that scenario we will simply reduce our space to this one, this much only now. Okay, so let's say, and if at some places there can be two possibilities, that at this left end this there can be 1 and here also it can be 1. Okay, or 0 or 0, so this is nothing but this one, this left hand and this left hand, but sorry, right hand. Similarly this is nothing but, what I'm trying to say is this 0 will be at this position, or this one, this is the leftmost or rightmost pointer position. So these are the two possibilities, right? And if it is different, we already know that if it is different we can simply ignore them and we can move forward. But if it is not, then we can see, can we insert something and make this good. So we know that we can always insert 0 1 as a substring, right? We cannot split just 0 or 1, we cannot split these, so we'll always have to insert this 0 1 as a whole. So let's say if we add 0 1 over here, does this make any effect? Because still we know that this position and should not be equal to this one, right? Because we cannot have, if we'll write something that a of I is not equal to a of k minus I plus 1, and here we saw that this was 1, and at the right end also we have 1, and if we insert this 0 1, we still have 1 at the rightmost end. So it doesn't matter, or it doesn't mean anything to insert 0 1 in the right position if we have 1 and 1. But if we insert 0 1 over here, so what will we will have? We will have something like this 1 over here, and we have inserted this 0 1 over this position. Then we will see that there is 1 0 over here and 1 over here. So in that scenario, we see that yeah, we kind of make this part good, and then we have only this much remaining to check. Okay, we have this much remaining to check. Else else if we have these two zeros, okay, so from here, just to conclude it over here, so what we realize is, if we have 1 and 1 at both leftmost and rightmost point, we always have to insert on the leftmost point, right? We can always insert 0 to on the leftmost point to further continue our process. We are not very sure till now that whether it's possible or not, or whether it will be good or not, but for the timing it will be good, right? Because here we will be something like the 0 1 1 with some number and 1, so we can simply cancel out this 0 and this 0 1, and we'll check on this remaining part. So here we can see, or we can say that we have to add 0 1 on the left. Similarly, if we'll check for this 0, if we'll add 0 1 on the left, what we'll see that this 0 and this 0 are still matching, so this is not the right way. So what we can do is, we have this 0, right? This 0 here on the left end and this 0 on the right end. But if we'll add 0 1 over here, we will see that this one and this 0 are different, and that's what our condition for good string, right? So then we have this remaining portion. Okay, okay, cool. So from here we have our conclusion that if both are equal and both are equal to 0, then we always insert in the right end, and if both are equal to 1, we insert in the left end. Now, we already know that this insertion process can be done at max three times. At max three times. So, anyways, we'll increase, even if we'll add in such a way, like see what we are doing, either adding from left or adding from right. It's not like that we will be adding somewhere in middle. So even if we'll add 300 times from the left or from the right, so at max we'll be just increasing 600 characters. That's not a big deal. We can easily handle this kind of time complexity if n is on the order of like 1000 or less than 1000 or 600, something like that. So like if you'll notice in the question, it's also that x will be less than 100, so overall the size will become at max 700, right? So that's nothing to worry about. We can simply run o of n square, anything we want, but we not don't need to worry about. Now the only thing we are concerned right now is, so we have this let's say different characters. Now if we know that if these are different, this and this are different, we can simply cancel this out. Now if we are canceling, okay, that's fine, let's cancel this. Now if this is different, sorry, if these two are same, these two are same, then we'll have to make an insertion. Now we already know that if this both are 1, then we have to insert on the left, right? We have already discussed over here that if it's both 1, we will have to insert in the left. If it's both 0, then we'll insert in the right. Okay, so we can simply insert over here. Now we know that if we are inserting over here, that means we'll have to write down the syntax. Yeah, so we'll have to write down this index, that which index we are inserting at. So it was basically 0, it was 1, so we are kind of shifting this entire string a bit left, so we are inserting at this position 1. Now how will we calculate this position? So see, we have already removed one character, right? That means the number of characters we are removing from the left will be, and if we are inserting anything, that means that will the index of that insertion will be equal to the number of characters we have removed from the left. I'll repeat it once again. Please listen carefully. So we have, let's say, this many. Okay, this was equal. Sorry, different. So we cut it out, or we can simply remove this. Okay, now these two were also equal, so we have removed this as well. Sorry, different, not equal. We're satisfying the condition, so it was different. Now in total we have removed two elements from the lab. Now if we'll insert somewhere, if we'll insert something over here, let's say if we insert something over here, then what will be that index? That is nothing but the second index, right? Because we are, even though we are saying that we are inserting over here, but we are kind of shifting this character a bit right. Okay, so we'll be in this string, we'll be inserting this at this position, right? So that will be the nothing but the second position. Now if we have inserted this, so it will I mean, just taking from here itself, we have this three characters, so write it down similarly, like I'll just mark three circles, and then we have this 0 1, right? And we have what that we have removed left, whatever variable you want, you can just keep it lr, that equals to 2. Okay, and we have inserted it, and now we'll continue our process checking here and here. Similarly, let's say if this 2 becomes 0, like let's say here it's 0. These are some random figures I have made, it's not, but let's say here it is 0. Okay, so let's say here it was 0. Okay, and here also it is 0, because we have inserted 0 0 right now. So in this scenario we know that we'll have to insert 0 1 in the right. So now if we are inserting in the right, then what will be the index, and what will be the index? So we can simply say that the number of characters we have already removed from the left, that is lr, let's say, and whatever the size we have right now, the string, and s dot size, can't we write that? So what I'm saying that if we are inserting something at the right, what we can say that the number of characters we have removed on the left plus whatever the size we have right now of this string, that will be the index we are inserting at. Okay, so from here what we are realizing that if at any position we are inserting, if we are in any position we are inserting, then for insertion on the left we can simply that the number of characters removed in the left, that will be the index for this left insertion. And if we are inserting something on the right, then we can simply write the left, we in the left how many characters we have removed plus what was the size of this remaining string, and then we can write down the position will be equal to that left removed plus size of the string, that will be the index for this right insertion. Okay, now it's cool, it's okay till here, but now we have to find something that where we will be able to, kind of inserting, say when we are saying that we are inserting at the left, so and we are also inserting at the right, so we can see that we are kind of, pushing elements from this front as well and pushing the element from the back as well. So do we have anything for something like this? Yes, we have a data structure called dq. So I'll just give a brief intro. What is dq? Dq is just nothing but a simple queue, but in this we can insert the element from both ends, and we can similarly pop the elements from the both ends as well. Okay, So now the question was reduced to nothing but very simple. So what we can do is we can simply make a DQ with all the characters we have. We can simply make a DQ of char. Why char? Because we will be comparing this character wise character. So we have this DQ for char. Now we can simply compare this. Okay, if it is not matching, then it's fine. We will remove this element and this element both. But if it is not matching, depending on the condition, whether we have 0 or 1, then we will see we are entering this side or we are adding elements this side. We can simply do that, and we'll keep on repeating this process. Meanwhile, whenever we will insert, we'll just keep a count like how many variable we are inserting or how many insertion we have already done, and we only need to insert 300 times, right? Though it would won't exceed, but let's say even if it was exceeding, if it exceeded, then we will simply break our loop and we can simply return our answer as no. But let's say within 300, this DQ becomes empty. This DQ becomes empty. That means what it means, that we have made this string a good string. Then in that scenario, what we can do, we can just print the like how many times we have made an insertion and the indexes for that. So let's come to the solution. So first of all, what we'll do, we'll take the input. Okay, I will check if the string is of odd length. We know that if it's odd, we won't be able to make it a good string, and we can simply return -1. Now, if not, we'll make a DQ. Okay, this LR is left remove. How many characters are removed in the left? That we are keeping count in LR. Now, this is the vector indexes. Why? Because we have to print the indexes where we will be inserting, right? And in the same order. Because let's say why in the same order, so let's say if we inserted somewhere here, but if the moment we inserted over here, it will become something like this one, right? 0 1 and then 0 1, something like this. So the indexes will be changed. So let's say if I made insertion over here and then I am saying that I have made an insertion over place 1, or let's say place, in this scenario it was 2, right? 0 1 2. So for this, even though it was 2, but here it will be changed because this two elements will be added and this will become 0 1 2 increased by 2, that will become 4. So order is very important. We can't say that first of all we inserted at place 2 and then inserted at place 1. So order is important. That's why we have this one, indexes. So we'll keep on inserting in the same order what we are inserting in here. So what we'll do, we'll first of all check, and yeah, there's one more variable, count, to keep count how many times we have inserted in the DQ, or like made the insertion of 0 and 1. And if it's that is greater than 300, we can simply break the loop by saying that it's not possible. We can simply print -1. Else what we can do, while DQ is not empty, we'll check if front and back are not equal. That means that is satisfying our condition, and we'll remove element from both front and end. And now we are increasing the value of left removed because we have to take into count while giving the indexes. And else if they are equal, that means we'll have to make an insertion. Then we can simply add count or increase count by 1. And if that is greater than 3, it is given in the question that at most we can do 300 operations. Okay, so if that is greater than 300, we can simply see out -1, saying that it's not possible to make it a good string, and we can simply return. Else else what we can do is, we can, depending on the condition we have already discussed, right, that if it's one, where it was, sorry, yeah, if it's 1, we'll have to make an insertion in the left, else we'll have to make an insertion at the right hand, right? So if it's 1, we are pushing in the front. So here you will see one thing, that I have pushed 1 first and 0 first. Why? Because in DQ, so let's say when you have to push 0 1 overall, right? So if you will push 0 first and then 1 first, then it will become something like this, 1 0, because we are pushing right in this direction. So that's why I pushed 1 first and 0 first, so that it became 0 1. Okay, I hope that would be clear. Similarly, yeah, and we can push this index, as we already discussed, that it will be LR. And similarly, if we are pushing on the rightmost end, that is, this value is equal to 0, that means we can simply do this operation. But before doing this operation, we'll have to push the index in this indexes array, and that will be left mode plus whatever the size of the string can be calculated from the size of the DQ. Okay, and now finally we can simply print this count, how many operation we did and what indexes, and we can finally terminate this loop and this function, I would say. Okay, so I submitted this solution and it was submitted in the contest, so it will be an easy solution. So but let me go know if you guys have any question over this question in the comment section. Okay, thank you guys, see you in the next video.